Our next speaker is Fritz Koster, and he's going to talk to us about linking size and age of attaining sexual maturation to growth and stock productivity in Atlantic cod stocks. Fritz?
Yes, thank you very much for giving me a chance to tell about something which actually is not really brand new, but where we have run into a problem, I would say. And if I'm saying run into a problem, we have run into a problem. Who is we? Well, that's actually Mike Fogarty and Anne-Johann Dalsgaard. We have, at a certain point in the synthesis phase of calling climate change, got the job to try to summarize what we have actually learned in relation to cod recruitment processes. And I mean, we are showing here the variation, standardized variation of recruitment for the Eastern Atlantic cod stocks, and as high as the variability, as difficult proved the job, and it has, due to that reason, also never got finalized, I'm afraid to say. So I'm trying to follow a little bit up on that. And the job was really to look into the different stocks around the North Atlantic basin. And the first thing we did, we were looking at Triple's paper from 1997, which is looking at age and sexual maturity. Here for the Western Atlantic, we did the same for the Eastern Atlantic. And there's quite a bit of data follow-up on the talk before. It is also available actually for the North Sea. So in principle, the data is there to construct maturity ogives. We looked into this and we have discussed it earlier. There's a trend here, but that's really not what was really interesting as. It was really the difference between the different stocks. There's obviously a north-south gradient to younger age at attaining maturity. That's not new either. If we are looking to the same length plot, average length at attaining sexual maturity, then one thing which I think is a little bit astonishing, it is really, if one is comparing stocks, it is not so that age at attaining maturity follows length. These stocks are behaving quite different. For example, the northern cod, which is the black one here, this one for the females and here for the males, are forming basically the bottom line of these figures. If we would go back here, we would see in relation to age, they are the ones which are the upper part of the figure. So what we try to do is we try to group the stocks. We try to group the stocks a little bit according to their latitude and to their temperature. And what we see here is average age and length at attaining maturity, and it is the range of the data throughout the 80s and the 90s. And for the Western Atlantic, there are more or less, with some variation, three groups of stocks visible. Those which are maturing early in life at small size, those which are maturing late at large size, and those which are late in life at small size. And there is, of course, a latitude gradient in it, with the latter ones, late in life, at small size, being the more northerly distributed stocks. There are also some stocks which are really not fitting exactly into the picture. For example, here the East Scotian Shelf. Then we have Flemish Cap. There I had some data problems though. So, I mean, if one is doing such a clustering, it is, of course, a rough thing. If we are looking now to the Eastern Atlantic and do the same exercise, and that is a little bit newer because it was a little bit of an effort to get the data together here. Then what we see there is basically a bunch which is maturing early in life, at large size, and at small size. This at large size, early in life, that did not exist in the North Atlantic. In contrast, in the Western Atlantic, in contrast, we are missing the group late in life at small size. We don't have that in the Eastern Atlantic. There we have large size. If one is trying to look further into it and then plotting the proportion mature against weight, knowing that maturation processes have something to do with growth, And additionally, putting in the age groups, and then we get examples for these four different classified stocks. Early in life at small size, here the Eastern Baltic. Early in life at large size, that is the North Sea. Late in life at small size, that's the Grand Bank, and Barents Sea for the other one. If one is then starting to look into the different stocks as far as the data is available, one of course sees that there is a grouping, but not all stocks really behave that nicely. For example, the Faroe Plateau stock, that is this one here, that is falling somewhat out. We will later see that it is actually somewhat an intermediate stock, though. There's also, of course, another thing, and that is sex. I mean, in principle, if one is using sex-specific data, one finds out that there is quite some variability in terms of that the sexes are behaving differently. Fortunately, they are not really completely off. Then there is, of course, also other things like interannual variability. So if one is doing this type of grouping, then that is a relatively rough and dirty thing. So we have grouped the stocks according to the first pattern, early in life at small size, and then we have related that to two classifications from Brander and Dutiel and Brander, publications in relation to growth classification and surplus production. The result of that is that early in life at small size are stocks which are showing low to intermediate, let's say intermediate growth and intermediate surplus production, while the ones which are fastest early in life at large size have high growth, some intermediate like Faroe, and intermediate to high surplus production. Those ones which are latest, smallest, have low consistently. And then we have the one which is the group which is large at size, late in life, that's mostly intermediate to high. And then one is, of course, asking oneself whether can one use this classification for anything? I mean, it's perhaps nice to know, but I mean, what are we going to do with that? And that is probably also the reason why I'm supposed to be in this session. And unfortunately, I cannot give really an answer to that. But I mean, at least we could look a little bit into it. According to Dutiel et al. In 2003 paper, less productive stocks live in cold, sometimes also oxygen-depleted waters, and are characterized by slow growth, condition on average lower and more variable. They become sexually mature later at age and at a small size. That's the small size category we have seen. They recruit at an older age. Okay, poorly productive stocks have a reduced reproductive potential. That was the conclusion of the paper. And then the question is, of course, can we see that by, for example, lower production of recruits? And what we so did was simply look into the different stocks, came with some sort of average recruitment per biomass. We started with biomass. Here we see the geometric mean to the right side of the table and some sort of standard deviation there. And it is as one would expect, so that in high latitudes and low latitudes, at the end of the distribution range, you can see that the productivity per biomass is lower. It is not necessarily so that there is a consistent trend in variability, but a certain, I would say, trend that is going along with higher variability. If we are looking into the Western Atlantic, we see basically the same picture. Again, it is so some of the stocks with low production have also high variability, some others don't. If we are now looking to the left side and follow the classification we have had before, red ones, that is the ones which are really the latest ones at smallest size. And we are looking to how their production per unit of biomass actually is, then we find out that's pretty mixed. There's quite a bit of those stocks which have relatively high production per biomass, and vice versa. If we are going into the Western Atlantic, basically the same picture. That is actually somewhat strange. Have we seen this one? No, I don't think so. That's the Eastern Atlantic one. Basically the same picture as we have seen from the Western Atlantic one. Low productivity does not necessarily go along with low productivity in terms of recruits per biomass, and vice versa. And the next question is, of course, we have asked us, is it actually a good idea to use the spawning stock biomass for this exercise? Because, I mean, originally we thought we wanted, of course, to know the impact of maturation. If we use the spawning stock biomass, we incorporate maturation in one way or the other. The picture does not change at all, it gets worse. So there is absolutely no trend in it. Less productive stocks are not really characterized by lower productions of recruits per unit of spawner biomass, or have higher variability. And this is also sustained if one is trying to standardize the recruitment and spawning stock biomass per area. And the recruitment of recruitment per spawner stock biomass is of course affected by a suite of different processes which are really acting on the early life stages. So it is perhaps also not really that a wonder that one cannot make that link easily. But that is basically then referring also to the problem Mark was talking about, where is actually the proof. The signal can, however, be followed into fecundity based on Ice's paper in 2005. If one is using that data, actually it is at least visible to take that classification into fecundity data, but not further on. At that point, we of course said, okay, that is not that simple, we changed it around. We now look simply to the description of the single stocks. What have the experts actually said is really critical for reproduction? And from that one, it follows actually that in 7 out of 13 really thoroughly worked through stocks, egg production in relation to nutritional condition and growth is identified as critical, and these are not surprisingly all the late maturing northern stocks. So after having made that way around from the other angle, we get at least to some sort of conclusion that if there is a signal, then we should probably target those stocks in the northern end of the distribution. Thank you.